In almost every gasoline engine, cylinders temporarily not needed while the engine is at part throttle can be deactivated to save fuel and thus reduce CO2 output. To be able to decide when the engine can shut cylinders off, the engine control unit constantly analyzes a number of parameters, including the following: the torque provided by the engine, the current engine speed, the vehicle speed, the gear currently engaged. When the driving situation allows for cylinders to be deactivated, the engine is made ready for the switch off. For the still active cylinders, that means having to help generate the torque otherwise contributed by the deactivated ones. To achieve this, the throttle valve opening is increased to prepare the part of the engine still being fueled for operation in deactivated cylinder mode. In order to meet drivers' performance requirements, the increased oxygen level in the combustion chamber must not lead to an increase in torque delivery, which would result in undesired vehicle acceleration. To ensure that the driver's desired torque is maintained, the throttle valve opening of the part of the engine to be deactivated is reduced accordingly. Furthermore, the ignition timing in the still active part of the engine is adjusted accordingly. Now the gas exchange valves will be deactivated. First, the exhaust gas valve, followed by a final intake of air, but this time without any fuel injected into it. Next, the closed intake valves are shut off. Now that the combustion chambers are deactivated, no further injections or ignitions occur there. Cylinder deactivated engine operation saves fuel in two ways. First, throttling loss due to an elevated oxygen level in the combustion chamber is reduced. Second, the partially deactivated charge cycle reduces torque loss. When driving requirements demand that the cylinders be reactivated, this occurs within just milliseconds. The combustion chamber is filled with fresh air. Injection and ignition resume immediately. Engine activities are thus carried out in a torque-neutral manner, imperceptible for the passengers in the vehicle. Cylinder deactivation is a highly effective measure to reduce fuel consumption and CO2 output of combustion engines, while meeting the most stringent demands for driving dynamics and comfort.
Bosch, invented for life.
Regenerative braking is the recovery of kinetic energy during braking. In a conventional vehicle, a majority of the kinetic energy is converted during friction braking into heat and emitted unused into the environment. Hybrid and electric vehicles can use the electric motor to recuperate at least a portion of the kinetic energy for reuse. When the driver steps on the brake, the vehicle's electric motor switches to generator mode. The wheels transfer the kinetic energy via the drivetrain to the generator. Through its rotation, the generator converts a portion of the kinetic energy into electrical energy. This energy is stored in a high-voltage battery. The generative braking torque of the electric motor, which is the result of energy generation, decelerates the vehicle. At low speeds, for example, shortly before the vehicle comes to a stop, the electric motor can no longer supply sufficient generative braking torque, and the friction brake must be activated. To maintain the required deceleration, the braking torque from the friction brake is continuously adapted to the current generative braking torque, a process called torque blending. In the case of full braking or an unstable driving condition, the vehicle is usually decelerated solely via the friction brake, as wheel-specific interventions are required. Regenerative braking enables an extended range in electric vehicles, as well as lowering fuel consumption and improving CO2 balance in hybrid vehicles. Furthermore, the use of the generator for braking reduces brake wear.
Bosch. Invented for life.
Driving in heavy traffic is hard work. The driver needs to concentrate at all times, respond quickly to new situations, and react by braking or accelerating. With adaptive cruise control from Bosch, ACC for short, driving is far more relaxed. ACC can take the pressure off the driver during the journey by adapting the speed of the vehicle to the flow of traffic. The driver is thus able to better concentrate on the traffic situation and is supported in maintaining the safety distance to the preceding vehicle. ACC is easy to operate. The driver selects the desired speed and sets the distance to be maintained from the vehicle ahead. This distance can be set at several levels, adapting to the driving situation and individual driving style. ACC is now active. A long-range radar sensor monitors the driving situation ahead of the vehicle. The sensor transmits radar waves that are reflected by objects in front of the vehicle. Based on this data, ACC can detect preceding vehicles and can calculate the distance, direction, and relative speed of the vehicle ahead. When the road ahead is clear, ACC maintains the set desired speed. When the system detects that it is approaching a vehicle, it interacts with the engine control or the braking system in conjunction with the electronic stability program ESP, and ensures that the set safety distance is maintained. Once the road ahead is clear, ACC automatically accelerates the vehicle to the desired preset speed. ACC supports harmonious traffic flow on the roads. Even when ACC is switched on, it remains the driver's responsibility to monitor the speed and distance from the vehicle ahead at all times. The driver can override or switch off the function at any time. The standard ACC can be activated from speeds of around 30 km per hour upwards and can support the driver, particularly on cross-country journeys or on freeways, up to speeds of around 200 km per hour. The ACC stop-and-go version is also active at speeds under 30 km per hour, right down to vehicle standstill. The system can maintain the set distance to the preceding vehicle even at low speeds and can brake down to complete vehicle standstill. When the vehicle ahead moves forward within a few seconds, the ACC vehicle follows automatically. When waiting times are longer, the driver needs only to reactivate the system, for example by briefly stepping on the gas pedal to return to ACC mode. In this way, ACC Stop and Go can support the driver even in heavy traffic and traffic jams. Both ACC versions can be realized by using just one long-range radar sensor. The tried and tested ACC functions can be further optimized via intelligent networking with surround sensors already installed in the vehicle. or by integrating additional video or radar sensor technology. This enables the ACC speed range to be extended from 200 to 250 kilometers per hour and offers increased dynamics when driving off from a standstill. The ACC sensor control unit is also a key component for implementing functions that enable a timely reaction to critical driving situations. More comfortable driving with adaptive cruise control from Bosch.
Bosch. Invented for life.
A brief distraction or loss of concentration can often be enough to cause the driver to leave the lane unintentionally. This can lead to serious accidents. Lane departure warning from Bosch helps the driver stay in the lane and can warn of an impending unintentional drift out of the marked lane. It can be enabled from speeds of 60 kilometers per hour or 40 miles per hour upwards. Lane departure warning uses a video camera to detect the lane markings ahead of the vehicle. It can identify up to 4 lanes, even in poor visibility situations. Even when one side of the lane marking momentarily disappears, the function remains enabled. Lane departure warning monitors the vehicle's position in its lane. When the function detects that the vehicle is about to unintentionally move out of the lane, it warns the driver by means of an audible, visual, and/or haptic signal, such as a steering wheel vibration. These warnings signal the driver that the vehicle is drifting off course, allowing him or her to counter-steer accordingly. The function does not issue a warning when the driver activates the turn signal to change lanes or turn intentionally. Helps you stay in the lane. Lane departure warning from Bosch.
Bosch. Invented for life.
My name is Belén Aranda Colas. I'm responsible for the product management for automated driving.
My name is Michael Fausten. I'm the project manager for automated driving. It's very fascinating working with these highly motivated people, with this team, which is working in the United States and in Europe, working all together day and night. I never had a team in such a special way.
97% of all accidents are caused by human failure. So a forward-thinking vehicle which takes over dedicated driving task would make the vision of accident and injury-free driving a reality.
The most surprising and fascinating experience for me was the first time really being sitting in this vehicle. There was a driver, but he's taken away his hands from the wheel. He was just doing nothing. And we were driving towards the end of the lane. There was a kind of a concrete wall and the car stopped on its own. And I was sitting there like, oh, that was giving me nerves, but it worked quite well.
We are working on sensors. We have to define the requirements for the new technologies, the sensor of the future. And we will have to think also about legislation. This will be the biggest challenges we will face.
Imagine you're getting old. One day you will lose the capability of safely driving a vehicle. So you will be stuck at home in your apartment waiting for somebody to pick you up. The better thing is having an automated vehicle. You just sit in, press the button, and the vehicle takes you to your children, to your friends, and you still stay mobile, even in higher ages.
We are very dedicated to support the society with our technologies to make their lives easier.
Automated driving can give a huge benefit to society in comfort and in safety, and I just want to give my share in that this will happen.
My name is Chris Mansley, and I'm a research engineer working on automated driving at Bosch. We are working on automating cars of the future, so the car can take over and you don't have to drive. The car drove by itself in our parking lot. It's dark. We all pulled out our phones and we videoed the car driving around, so you can just see headlights driving. But the next day we sent this video to our colleagues and we were having a phone conference, and when they saw the video, a huge cheer erupted because this is the first time we had our car driving autonomously. And it was an amazing feeling. We really are going to do this. This is going to happen. So the most important thing to detect is obviously vehicles when you're driving in the highway. So radars are a great example of technology being fitted perfectly to the application. We are obviously working on ways of detecting new and novel environments. So as you move into urban environments, children, people, these are all things that we want to detect. In the United States, when you go into robotics and robotics-assisted technologies, sort of in the back of your head, you worry that you're going to be working for a defense contractor. And what I like about this project is it's exactly the opposite. It's making robots to save people's lives. In the 1950s, here in the States, science fiction was always predicting more than it could offer. But on this project, we're actually doing the things that we predicted in the past, that we're actually building the future here. It's going to change infrastructure in cities. We're going to be able to walk more, bike more, and have a nicer planet because we can use all these technologies to get people to where they need to go in the most reliable and safe way possible.
My name is Kevin Watts, and I'm a research engineer at Bosch. I'm responsible for mapping and localization for automated driving. I wanted to work in an area where robotics and autonomous technologies could be broadly useful to people, and I thought driving was a major unsolved challenge that we'll be able to solve in the next 5 to 10 years. In order to drive automatically, we need to be able to perceive objects in the world around us, like other cars, bicycles, pedestrians. We also need to know where we are, so we can drive in our lane, but also so we can do things like exit the freeway and make turns. The first step to determining our position is to build a map. We can't just use a map that you find in a satellite navigation system. We have to build it ourselves. We take our sensors and we drive the roadway several times. We use our sensors and we use the GPS readings to build a map of what the expected sensor readings are at each given location. Then, when we drive the roadway automatically, we compare the sensor data to the map. The biggest challenge is dealing with very uncertain scenarios, where there's an accident in front of you and the police officer is directing traffic, or snow or some type of environmental condition obstructs the roadway, so you really can't tell where you are. In the future, people will be able to drive longer and later in life, and they might be able to start driving earlier. Also, automated driving is going to allow us to drive with less accidents.
My name is Søren Kamel and I'm responsible for the planning system of our automated car. I've seen those cars many years ago and I've seen them how they slowly evolve from crawling along a sand road, going into the cities and doing driving with pedestrians around, with parking themselves, everything. And I think now is the time to bring that to the market and I really want to work on that. For the blending component, you take a model of the environment, you take a localization point on a map, you take a road network, and you have to determine where you want to go and how you get there. Then you have to go to a final level where you also have to determine, should I stay in this lane, should I do a lane change, should I follow this car, should I take a different route? And as a result of that decision-making process, in the end you would get a trajectory that then would determine how you would drive along a road and how to get there and with what speed you get there. Well, the driving strategy is basically what the human normally would do, and it's mainly also responsible if you feel safe in the car and if it matches your style. If you think of the future with automated driving, then there's no getting from one point to the other anymore, where you have really a transition between that. It's just there for you. You can take the time to do whatever you want there. You save hours every day.
Mein Name ist Janine Schwarzkopf und ich arbeite an der Bewegungsregelung für das Projekt Automatisiertes Fahren. Wenn wir eine Fahrstrategie haben, gilt es, die umzusetzen. Auch ein Mensch braucht seine Arme und Beine, um dann letzten Endes zu lenken und Bremse oder Gaspedal zu betätigen. Und das macht eben die Fahrzeugbewegungsregelung. Meine Motivation, in dem Projekt zu arbeiten, ist vor allen Dingen, also einmal das Thema ist super spannend, dann sind wir ein sehr junges Team, sehr international aufgestellt und es macht einfach Spaß, mit den Leuten an diesem Thema zu arbeiten. Ich denke, eine der größten Herausforderungen für die Zukunft ist das Thema Sicherheit. Dass einmal die Sensorik eben sicher das Umfeld erfassen muss und jede Situation erkennen muss. Und dann unter anderem auch, dass die Steller immer verfügbar sein müssen. Also man muss über Redundanz nachdenken und letzten Endes das Fahrzeug immer sicher in einem sicheren Zustand zu halten. Sprich auch, wenn Sensorik ausfällt, das Fahrzeug noch sicher an den Seitenrand zu fahren. Automatisiertes Fahren wird die Zukunft vor allen Dingen dahin verändern, dass Menschen, die viel Zeit im Auto verbringen, diese Zeit nutzen können, um was zu lesen, vielleicht eine Zeitung zu lesen, auch vielleicht schon für die Arbeit irgendwas vorzubereiten und die Zeit besser nutzen können.
Mein Name ist Michael Helmle. Ich kümmere mich um Konzepte für Validierung und Freigabe. Das automatisierte Fahren ist wesentlich komplexer als gegenwärtige Fahrfunktionen und gleichzeitig muss das Risiko, weil diese Funktion das Fahrzeug komplett unter Kontrolle hat, wesentlich besser abgesichert sein. Mit gegenwärtigen Methoden würde man da mehrere 100.000 Jahre Fahrabsicherung benötigen. Und wir sind auf der Suche jetzt nach neuen Methoden, um diesen Aufwand zu reduzieren und leistbar zu machen. Also Also das Thema ist halt so spannend, weil es überhaupt kein Konzept bislang dafür gibt. Das heißt, da muss man eigentlich sehr breit interdisziplinär arbeiten. Das heißt, ich arbeite mit Experten mit unterschiedlichem Background, die alle eigene Fachtermini haben und eigene Anschauungen. Das heißt, da muss ich sehr offen sein und über meinen Tellerrand hinaus gucken, damit da was entsteht. Ich hoffe, dass das hochautomatisierte Fahren, wenn ich erfolgreich mit meiner Validierung bin, dann dazu führt, dass das Fahren viel sicherer wird, als es heute ist. Gleichzeitig entsteht da ein hoher Gewinn an zusätzlicher Freizeit. Ich gehöre auch zu den Mitarbeitern, die jeden Tag 2 Stunden auf der Straße sind, was für mich verlorene Zeit ist, und da hoffe ich mir eine deutliche Verbesserung.
Moderne Bremssysteme verhindern viele Unfälle. So haben ABS und der Schleuderschutz ESP bereits vielen tausend Menschen das Leben gerettet. Um das Fahrzeug abzubremsen, gibt es im Fahrzeug einen Bremskraftverstärker. Er verstärkt die Bremskraft des Fahrers und sorgt für ein sicheres und komfortables Bremsen.
Konventionelle Bremssysteme verwenden ein Vakuum, welches durch den Verbrennungsmotor erzeugt wird für die Bremskraftverstärkung. Bei Fahrzeugen mit einem elektrischen Antrieb steht dieses Vakuum nicht mehr zur Verfügung. Deshalb haben wir den sogenannten I-Booster entwickelt, der mit einem Elektromotor die Bremskraftverstärkung durchführt.
Dadurch kann das Pedalgefühl beim Bremsen frei gestaltet werden. Viele Automatikautos bieten schon heute verschiedene Fahrmodi, von Eco bis Sport. Künftig könnte auch die Bremse entsprechend sanft oder aggressiv zupacken. In Gefahrensituationen dauert es kaum mehr als einen Wimpernschlag, bis der Elektromotor des Bremskraftverstärkers eine Vollbremsung eingeleitet hat.
Durch den schnellen Druckaufbau des I-Boosters kann in Kombination mit einem automatischen Notbremssystem nahezu die Hälfte aller frontalen Unfälle mit Fußgängern vermieden werden.
Beim Bremsen geht die Energie bislang als Wärme verloren. Elektro- und Hybridfahrzeuge können einen Großteil dieser Energie zurückgewinnen. Dafür bremsen sie nicht mit den Radbremsen, sondern mit ihrem Elektromotor. Wie ein Fahrraddynamo wandelt dieser die Bewegungsenergie in elektrische Energie um und speichert sie in der Batterie.
Der I-Booster entscheidet, ob der Elektroantrieb des Fahrzeuges bremst oder zusätzlich die Radbremse hinzugezogen werden muss. Der Fahrer merkt von diesem Wechselspiel nichts. Das Pedal fühlt sich ganz natürlich an. Was er allerdings merken wird, ist, dass die Reichweite seines Elektroantriebes sich deutlich erhöht aufgrund der Rückgewinnung der Energie beim Bremsen.
Laut Bosch erhöht sich dadurch die Reichweite des elektrischen Antriebs, je nach Auslegung des Fahrzeugs um bis zu 20%. Moderne Bremssysteme verhindern also nicht nur Unfälle, sie senken den Verbrauch und machen das Auto umweltfreundlicher.
Modern braking systems prevent many accidents. ABS and ESP skid protection have already saved many thousands of lives. To slow the car down, a brake booster is used. It boosts the driver's braking force and makes braking safer and more comfortable.
Conventional systems use a vacuum to boost the brake force of the driver. This vacuum is supplied by the combustion engine in vehicles with an electric engine, e-vehicles. This is not available anymore. That's why we developed a so-called I-booster, a system which is independent of vacuum and increases the brake force by electric motor.
This allows the pedal feel while braking to be customized. Many automatic vehicles already offer various driving modes, from eco to sporty. In the future, the brakes will also be able to engage in different modes, such as softly or aggressively. In dangerous situations, the electric motor triggers a full braking maneuver from the booster in the blink of an eye.
Due to the high pressure buildup within the I-booster in combination with an automated emergency braking system, nearly half of the frontal accidents with pedestrians can be avoided.
When braking, a lot of energy is lost as heat. Electric and hybrid vehicles can recover a large part of this energy. To do this, they brake with the electric motor instead of the wheel brakes. Similar to a bicycle dynamo, this kinetic energy is transformed into electrical energy and stored in the battery.
The I-booster decides whether the engine of the vehicle brakes or the wheel brake is needed. The driver will not notice this. The pedal feels completely natural. What he will notice is that the range of his electric engine will be increased due to the recovery of energy during braking.
According to Bosch, this can increase the range of electric drives by up to 20%, depending on vehicle design. Modern braking systems thus not only prevent accidents, but are also environmentally friendly.
Schnelle Bremssysteme verwenden ein Vakuum, welches durch den Verbrennungsmotor erzeugt wird für die Bremskraftverstärkung. Bei Fahrzeugen mit einem elektrischen Antrieb steht dieses Vakuum nicht mehr zur Verfügung. Deshalb haben wir den sogenannten I-Booster entwickelt, der mit einem Elektromotor die Bremskraftverstärkung durchführt. Durch den schnellen Druckaufbau des I-Boosters kann in Kombination mit einem automatischen Notbremssystem nahezu die Hälfte aller frontalen Unfälle mit Fußgängern vermieden werden. Der I-Booster entscheidet, ob der Elektroantrieb des Fahrzeuges bremst oder zusätzlich die Radbremse hinzugezogen werden muss. Der Fahrer merkt von diesem Wechselspiel nichts. Das Pedal fühlt sich ganz natürlich an. Was er allerdings merken wird, ist, dass die Reichweite seines Elektroantriebes sich deutlich erhöht aufgrund der Rückgewinnung der Energie beim Bremsen. Der I-Booster ist hier an der Karosserie angeschraubt, ragt in den Fahrerraum, in den Fußraum. Das Pedal ist hier angebracht. Der Fahrer drückt hier auf das Pedal, bewegt den Kolben in diese Richtung. Parallel dazu treibt der Elektromotor über dieses zweistufige Getriebe ebenfalls in diese Richtung. Die Kräfte werden hier zusammengeführt. Der Hauptbremszylinder, dort wird der Druck aufgebaut und geht an die Radbremsen zum Bremsen. Conventional systems use a vacuum to boost the brake force of the driver. This vacuum is supplied by the combustion engine in vehicles with an electric engine, e-vehicles. This is not available anymore. That's why we developed a so-called I-Booster, a system which is independent of vacuum and increases the brake force by electric motor. Due to the high pressure buildup within the I-Booster in combination with an automated emergency braking system, nearly half of the frontal accidents with pedestrians can be avoided. The I-Booster decides whether the engine of the vehicle brakes or the wheel brake is needed. The driver will not notice this. The pedal feels completely natural. What he will notice is that the range of his electric engine will be increased due to the recovery of energy during braking. The I-Booster is fixed to the driver compartment here. The pedal is in this area, pushing in this direction. In parallel, the electric motor is also supporting the force via the two-stage gear in this direction. Here, the two forces are added. The pressures build up in the master cylinder and then going to the wheels for braking.
Das können wir dann schneller laufen lassen.
My smartphone assists me throughout my day. It carries my personalized music, my contacts, my emails, and many more valuable apps that support me in all my activities. How did I live before my smartphone became my personal assistant? When I connect my smartphone to my car, the apps on my smartphone are displayed through my spin on my vehicle's infotainment system. My smartphone renders the apps and transfers the video image to the vehicle's display. The home screen shows all the apps that are compatible with my vehicle. To control my apps, I use my vehicle's display. Any touch event is forwarded to my smartphone. I can, of course, access all the classic apps available on my smartphone, such as my calendar, my contacts, my music player, or maps. Let's have a look at my calendar. I can access my events and even select event locations, such as destinations, for my favorite navigation app. Of course, my Spin also supports my Bosch smartphone navigation app. I have access to all the same features as on my smartphone: destinations, routes, traffic, and more. The look and feel of the app are the way I'm used to it from my smartphone, which is specially designed to be easy to use. The app interface has been optimized to be used in my vehicle. The fonts are larger and focus is given to those features that are important whilst driving. I'm no longer distracted by information overload. My Spin enhances driving safety whilst giving me access to a wide range of smartphone apps. My Spin supports me not only whilst driving, but also when I leave the vehicle. I can get information on the location of the nearest service point, or special offers for my vehicle. The app's board computer reminds me when my car needs its next service, and with the OEM customer relation management, it is even possible to book the car service online. My apps, my car, my Spin.
Facebook, Twitter und Co. Das Internet ist aus unserem Leben nicht mehr wegzudenken. Experten sind sich sicher, in den kommenden Jahren wird es auch die Welt des Automobils verändern. Bereits heute empfangen Navigationsgeräte Stauinformationen über das Internet und suchen mit Google nach Sehenswürdigkeiten.
Heute ist ja die Situation im Fahrzeug so, dass wir das Internet quasi ins Auto holen über unsere mitgebrachten Smartphones. In der Zukunft wird es so sein, dass das Fahrzeug, das Auto selber, ins Internet geht. Dies kann beispielsweise über eine verbesserte Smartphone-Integration oder dedizierte Kommunikationsmodule passieren. Und der entscheidende Punkt ist hierbei, dass wir unserem Endkunden einen Mehrwert bieten. Das kann beispielsweise dadurch passieren, dass das Fahrzeug als Sensor fungiert, aktuelle Daten in die Infrastruktur liefert und auf Basis dieser Daten dann beispielsweise ein verbesserter aktueller Verkehrsfluss oder eine Gefahrenwarnung berechnet wird.
Bereits heute verfügen Fahrzeuge über verschiedene Sensoren, mit denen sie sich und ihre Umgebung erfassen. In Zukunft können sie diese Informationen über das Internet mit anderen Fahrzeugen und Anwendungen austauschen.
Stellen Sie sich einmal vor, Sie sind auf einer Landstraße und haben einen Unfall. Zugegebenermaßen ein extremes Beispiel. In diesem Fall setzt Ihr Fahrzeug automatisch einen Notruf ab. Das nennen wir eCall. Und dieser Notruf wird dann von den Rettungskräften aufgenommen und bearbeitet. Durch diese automatisierte Bearbeitung erfolgt eine wesentlich schnellere Anfahrt zum Unfallort. Und Untersuchungen haben gezeigt, dass man dadurch die Hälfte der gesamten Anfahrtszeit einsparen kann. Und dies kann im Extremfall sogar Leben retten. Zudem kann diese Information dann auch genutzt werden, um nachfolgende Fahrzeuge zu informieren, um dadurch Folgeunfälle entsprechend zu vermeiden.
Eine weitere Anwendung ist die Erkennung von Tempolimits und Baustellen mit einer Kamera. Navigationsgeräte können so den Fahrer in Echtzeit über die erlaubte Geschwindigkeit oder Baustellen informieren.
Wir gehen davon aus, dass bis zum Jahr 2025 praktisch jedes Neufahrzeug mit dem Internet verbunden sein wird und dass bis zu diesem Zeitpunkt auch eine entsprechende Infrastruktur für Car-to-Car-Kommunikation etabliert sein wird. Auf der Basis wird die eben beschriebene Kommunikation zwischen Fahrzeugen dann automatisch erfolgen und wir werden einen weiteren Zugewinn in Sachen Verkehrssicherheit erleben können.
Die Vernetzung von Verkehrsdaten ist auch Voraussetzung für automatisierte Funktionen wie den Autobahnpiloten. Dieser fährt auf Wunsch von ganz allein. Autohersteller und Zulieferer wollen so dem unfallfreien Fahren einen großen Schritt näher kommen.
Facebook, Twitter, and co. We can't imagine our lives without the internet anymore. One thing experts are sure of: over the next few years, it will radically change the automotive world too. Navigation devices already receive information on traffic jams over the internet and search for local tourist attractions on Google.
Today we use our brought-in devices, our smartphones, to connect to the internet in the car. In the future, using smartphone integration and dedicated communication modules, the car itself, the vehicle, will connect to the internet. So we have a much higher degree of connectivity. We do this in order to increase the value for the end customer. And one example for this is to use the vehicle as a sensor in order to increase actuality of traffic data or actuality of obstacle information in order to prevent accidents.
Vehicles already contain multiple sensors with which they monitor themselves and their surroundings. In the future, they will be able to exchange this information with other vehicles and applications over the internet.
Imagine, for example, that you have an accident on a country road. In this case, the vehicle will automatically send a message, a so-called e-call, to the emergency service in order to inform about position and time of the accident. This leads then, in effect, to a reduction of the travel time of the emergency service by 50%. And in certain cases, this can save lives. Additionally, this information can be used to warn subsequent vehicles about this accident. And this, in effect, will reduce the likelihood of additional accidents in this region.
An additional application is the recognition of speed limits and construction sites with a camera. Navigation devices can use this to inform the driver in good time about upcoming speed restrictions or construction sites.
So we expect that latest in the year 2025, all new vehicles will be connected to the internet, and that the infrastructure for car-to-car communication will be available. This will lead to the fact that information between cars will be exchanged in real time, and that driving will become more safe and comfortable.
The networking of traffic information is also a prerequisite for automated functions, such as the highway pilot, which on request can drive the car by itself. With this, automakers and suppliers want to come a significant step closer to accident-free driving. Modern cars offer drivers a multitude of comfort and convenience functions, from audio and navigation systems to smartphone integration. This new infotainment system doesn't just link up all these functions within the car, it's also connected with the internet. Drivers can expand and customize the Bosch open source-based system with apps, just like a smartphone.
The user-friendly system enables me to control all my navigation and information, as well as audio functions via voice, without distracting me from driving.
Previously, drivers had to memorize specific voice commands in order to, say, tell the music system what song to play. This is no longer the case. In this car, the system can be controlled with natural voice input. Drivers can speak as they would with other passengers in the car.
Now I'm well on my way without taking my hands off the wheel. While driving, I like to listen to the music, and even that I can control via voice. Play Daft Punk.
Alternatively, drivers can operate the system with a touchscreen, like a tablet computer. Up to 10 connections can be managed and controlled via the central control unit, from cell phones to USB sticks to memory cards.
Bosch, invented for life.
race a slalom, or drift around a bend. A touch of a button is all it takes to change the setup. Up to now, this has only been possible in motor racing, but now regular cars can join in.
We developed a new integrated vehicle dynamics control to coordinate multiple actuators. We realized several driving modes. So we have a safe mode with which the car is driving like on rails. We have a sport mode to achieve best lap times on handling track. And we've got a drift mode for having fun on closed roads. With this function, the car manufacturer can change the driving behavior of his different cars very easily. And besides the increased safety, the customer has really fun.
The system will initially be installed in small series. Setups selected by race drivers could conceivably also be downloaded.
Okay, jetzt drück mal auf Save. Sport. Nochmal Save. Verändert aber Parameter. Jetzt nochmal auf Save.
Unser System steuert die Bremse und die Hinterachslenkung in diesem Fahrzeug an. Mit diesem Tablet können wir die Fahrdynamik des Fahrzeugs über vordefinierte Modi verändern. Wir haben einen Safe-Mode, mit dem ein Fahren wie auf Schienen realisiert wird. Wir haben einen Sport-Mode, mit dem die optimale Rundenzeit auf der Rennstrecke erreicht werden kann. Und es gibt einen Drift-Mode zum Spaß haben auf der Rennstrecke. Der Fahrzeughersteller kann durch dieses System die Fahrdynamik seiner Fahrzeuge sehr schnell verändern und der Kunde hat neben dem sicheren Modus zusätzlich jede Menge Fahrspaß. So we developed a new integrated vehicle dynamics control to coordinate multiple actuators. We realized several driving modes. So we have a safe mode with which the car is driving like on rails. We have a sport mode to achieve best lap times on handling track. And we've got a drift mode for having fun on closed roads. And we have the custom mode where the driver can change parameters like stabilization, balance and steering response independently to have a good setup like a race driver on a track. With this function, the car manufacturer can change the driving behavior of his different cars very easily. And besides the increased safety, the customer has really fun.
This car features a new system that informs drivers about what they can expect along their route.
In this display, you see some curve characteristics. There's a left curve or right curve and the optimal vehicle speed. So the system gives the driver the information which is the right velocity, so the driver can drive safely through the next curves.
In addition, the system shows how far it is to the next bend and how far the car is exceeding the recommended speed for that bend. The system computes this information with the help of the current position and maps. One further new development is linking this with the ACC, the automatic cruise control. This automatically sets the recommended speed.
I set a velocity of 100 kilometers per hour, and the system now sets exactly the speed which we can see here in the display. So I only have to use the steering wheel, and acceleration and deceleration comes from the system.
This is especially advantageous for hybrid vehicles. The system can preview the route and decide whether to select the electrical drive or combustion engine. This interaction of engine management and navigation system can reduce fuel consumption by up to 15%.
Okay, perfekt.
Wir befinden uns hier in einem Hybridfahrzeug. Das heißt, wir haben einen Verbrenner und eine E-Maschine, die gemeinsam koordiniert werden können. Das System haben wir jetzt mit dem Navigationssystem gekoppelt. Und was damit möglich ist, sehen wir jetzt. So, was wir jetzt hier sehen in dieser Anzeige, sind die nächsten 2 Kurven. Die Geometrie der Kurve, Linkskurve, Rechtskurve, scharfe Kurve und die ideale Geschwindigkeit, mit der man diese Kurve befahren kann. Das ist besonders dann interessant, wenn man den Weg nicht kennt, die Straßenbeschaffenheit nicht kennt. Das ist ein Assistenzsystem, das den Fahrer unterstützt, immer die richtige Geschwindigkeit einzustellen. 41 wird hier empfohlen, sehr komfortabel. 41 sehen wir, haben wir jetzt erreicht. Wir befahren die Kurve sehr gemütlich, sicher und effizient vor allem, ohne dass der Fahrer Gas oder Bremse betätigen muss. Das ist eine Schnittstelle, die von einem Navigationssystem zur Verfügung gestellt wird. Die Navigationssysteme der nächsten Generation werden diese Schnittstelle bieten. Und das ist die Basis für solche Funktionen, die wir hier gerade sehen. Das heißt, über GPS ermittelt man, wo man gerade ist, und das Navigationssystem sagt einem, was in den nächsten 2-3 Kilometern passieren wird. Also auf diesem Display sieht man die Energieflüsse. Dieses Fahrzeug ist ein Hybridfahrzeug. Hier ist sehr schön dargestellt, wann wir elektrisch fahren, wann der Verbrenner dazu geschaltet wird und wann wir rein elektrisch fahren. In dem Fall bis jetzt zu sehen ist, geht die Energie vom Verbrenner zu den Rädern und zur Batterie, das heißt über den Generator wird die Batterie geladen und gleichzeitig das Fahrzeug bewegt. Sobald wir Geschwindigkeit reduzieren, so in dem Fall wird rekuperiert und die Energie von den Rädern zur Batterie gespeist. Also so ein System, was wir jetzt hier sehen, hat mehrere Aspekte, die sinnvoll sind. Zum einen ist es der Komfort, den wir gerade sehen. Das Fahrzeug fährt teilautomatisiert, der Fahrer muss lediglich nur das Lenkrad bedienen. Darüber hinaus wird die Sicherheit erhöht, gerade auf Strecken, die man nicht kennt. Auf kurvigen Strecken wird hier die ideale Geschwindigkeit eingestellt und somit die Sicherheit bewahrt. Gleichzeitig lässt sich aber auch die Effizienz steigern. Durch diese Vorausschau lässt sich in der Motorsteuerung die Betriebsstrategie anpassen, sodass im Vorhinein entschieden werden kann, ob die Batterie geladen wird, ob wir rein elektrisch fahren oder hybridisch. Messungen haben ergeben, dass wir so 5-15% Effizienz gewinnen können durch ein solches System. So what we have here is a hybrid car. So we've got a combustion engine combined with an electric engine. And what we've done in this car is the interaction with the navigation system. And what features are possible with this system you will see now. In this display you see some curve characteristics. There's a left curve or right curve and the optimal vehicle speed. So the system gives the driver the information which is the right velocity, so the driver can drive safely through the next curves. You can hear this. The combustion engine is not started now. It's a Bosch hybrid system which enables the driver to drive around 50 or 60 kilometers per hour. This integration of navigation data, the next step can use for automated driving. For this we interact with the ACC, Adaptive Cruise Control, an intelligent vehicle speed controller. For this I activate the system. I set a velocity of 100 kilometers per hour, and the system now sets exactly the speed which we can see here in the display. So I only have to use the steering wheel, and acceleration and deceleration comes from the system. In this display we see the energy flow. In this way the energy goes from the wheels to the battery. It's called recuperation. Now the energy goes from combustion engine to the wheels. And another mode is the pure electric driving, when the energy goes from the battery to the wheels. With this system, we can increase the efficiency around about 5 to 15%, depending on road characteristics. So, because we know about the vehicle speed of the future, we can adapt the combustion engine and the hybrid system, and know exactly when to charge and when to drive pure electric. So it's not only a driver assistant function, but also efficiency functionality. So the base for this functionality is electronic horizon. That's an interface of navigation systems of the next generation, and this interface gives you information about the next 3 to 5 kilometers, if you have got a curve, if you've got speed limits, informations about street characteristics.
Passt.
This car steers brakes, and accelerates on its own. It drives completely automatically. Up to now, this has mainly been the stuff of science fiction films. Now Bosch is the first supplier to test a completely automated car on public roads in Germany.
We are not only testing on US highways, but also on the German Autobahn, because it's more challenging. And we need this data for the further development of our functions. We want to improve the safety on public roads. So 9 out of 10 accidents are caused by human failure. So if we automate dedicated functions, we will reduce the number of accidents.
To make this possible, several sensors monitor everything that is happening around the car. So if other cars have already entered an intersection, it detects this and only turns when the road is clear.
You can decide to drive on your own every time, but for dedicated situations like a traffic jam or a very, very boring street, the car will take over all the driving situations for you, and you can relax and use the time in a more productive way.
A chauffeur for everyone. As soon as 2014, a partly automated system in the form of a traffic jam assistant will go into series production. Fully automated driving on freeways can then become reality step by step over the next 5 to 10 years. Construction zones on the freeway are a source of stress for many drivers. Accidents are often the result. A new Bosch system supports drivers in this difficult situation.
The construction zone assist is based on a Bosch stereo vision camera system, which is located in the front of the windshield. And the stereo vision system basically is 2 cameras. Like every human has 2 eyes, which give them the possibility to have a 3-dimensional vision. So the system has a 3-dimensional vision and can detect objects on the side of the road. For example, borders in a construction zone, or pylons in a construction zone, or a truck. And so the system can help you to stay away from these objects to make driving in a construction zone safer and more stress-free.
If the camera notices that the car is getting too close to the edge of its lane, it gently steers it back to the center. If there is not enough space, it can warn the driver by flashing up a warning on the windshield or by emitting an acoustic signal.
The construction zone assist is a driver assistance system, which means that the driver is in control of the car at all times. The system helps the driver through a construction zone by giving him an input on the steering wheel, but the driver can at all times counter these interactions and decide that he wants to go in a different direction than the system wants to go.
In the future, similar assistance systems could also support drivers in city driving.
Der Baustellenassistent, der basiert auf einer Bosch Stereo-Videokamera. Die ist in der Frontscheibe verbaut. Das System besteht aus 2 Kameras, so wie die menschlichen Augen auch 2 Augen immer vorhanden sind. Und damit kann das Fahrzeug oder das System räumlich sehen und so Objekte am Straßenrand erkennen, Leitwände, Pylonen, Barken oder auch LKWs und somit Abstand von diesen Objekten halten, damit das Fahrzeug als auch die Insassen keinen Schaden nehmen und das Fahren in Baustellen stressfreier wird. Der Baustellenassistent ist ein Fahrerassistenzsystem, das heißt, der Fahrer ist immer in der Kontrolle über sein Fahrzeug. Das System hat begrenzte Eingriffsmöglichkeiten, die der Fahrer jederzeit überstimmen kann. The Construction Zone Assist is based on a Bosch stereo vision camera system, which is located in the front of the windshield. And the stereo vision system basically is 2 cameras, like every human has 2 eyes, which give them the possibility to have a 3-dimensional vision. So the system has a 3-dimensional vision and can detect objects on the side of the road. For example, borders in a construction zone, or pylons in a construction zone, or a truck. And so the system can help you to stay away from these objects to make driving in a construction zone safer and more stress-free. The Construction Zone Assist is a driver assistance system, which means that the driver is in control of the car at all times. The system helps the driver through a construction zone by giving him an input on the steering wheel, but the driver can at all times counter these interactions and decide that he wants to go in a different direction than the system wants to go.
In this situation, the driver would barely have had a chance. Modern driver assistance systems provide support in critical instances. This camera can prevent accidents involving pedestrians. The new Bosch stereo video camera can see in 3D and detect movement.
The stereo video camera is able to measure the position and movement of objects and persons in front of the vehicle. Therefore, we are able, if a pedestrian steps onto the drive lane, to ensure the safety by applying an emergency brake if it's necessary.
By comparison, it takes just over half a second for a human being to react. In a car traveling at 50 kilometers per hour, this means 8 meters without any braking. If pedestrian protection is installed, full braking is initiated 3 times more quickly, thus preventing many accidents. From 2016, any car wishing to receive the top Euro NCAP rating will have to have pedestrian protection on board. Many drivers find the high cost of fuel irksome. One alternative is CNG, compressed natural gas.
CNG is an attractive fuel. It contains high energy, it burns practically particulate-free, and it offers 25% CO2 saving. If made from biological resources, the CO2 saving can be increased even further.
One special feature of the CNG car is that it has 2 fuel systems, one for gasoline and one for natural gas.
The Bosch CNG system is switching smoothly between CNG and gasoline. Normally we try to extend the range of CNG, which means we start in cold conditions also on natural gas to ensure that the driver has the chance to go on cost-effective CNG.
The system can switch easily between natural gas and gasoline while it is in motion. The driver does not notice any switch.
This gives the driver the freedom to have a filling station available whenever is needed. So if there is no CNG filling station around, he can simply run on gasoline.
A CNG car can pay off as soon as annual mileage exceeds 7,000 kilometers, but for the driver, it's just like a normal engine. Driver will start-stop systems from city traffic. The engine switches itself off while stopped at a traffic light. Bosch has now taken this principle one step further. The new electronic clutch also now allows the engine to be switched off while driving in order to save fuel.
We prevent the engine drag torque during driving, and we have a CO2 benefit up to 7% additionally in the WLTC. During driving at a traffic jam, we have a comfortable driving due to the electronic clutch at first and second gear, similar to an automatic transmission.
Even with a manual transmission, the car drives like an automatic, at least in first and second gear. Hybrid powertrains are also comfortable and efficient. The Boost recuperation system is the new entry-level hybrid from Bosch. It supports the internal combustion engine with 10 kilowatt and can recover energy extremely effectively.
The main benefit of the Boost recuperation system, first of all, is the CO2 reduction or fuel reduction in the WLTC over 15%. Further on, we have additional benefits like recuperation. During the braking phase, we are collecting energy, and afterwards this energy can be brought onto the road by the electrical machine with additional torque.
During boosting, the electric drive supports the combustion engine. This allows the car to accelerate more powerfully. In addition, the engine can be started quietly and with a minimum of vibration. The Boost recuperation system is thus not only more economical and better for the environment, it makes the car more fun to drive and comfortable to start.
Our flexible engine management system, Motronic for natural gas injection, enables you to operate your vehicle on either gasoline or natural gas as you wish. The Motronic for natural gas injection system manages both fuel systems, which means that a switch between the two types of fuel during a journey is possible, with no change in torque output. Integrating both systems in a single bi-fuel management unit reduces installation costs and offers optimization potential for the entire system.
Bosch. Invented for life.
Ist nicht nur sportlich, sondern auch sparsam. In ihm steckt ein sogenannter Plug-in-Hybrid. Das heißt, die Batterie kann nicht nur während der Fahrt geladen werden, sondern auch an einer Steckdose. Der Vorteil: Das Auto kann sofort elektrisch losfahren und verbraucht insgesamt weniger Kraftstoff.
Bosch deckt das komplette System vom Verbrennungsmotor bis hin zum elektrischen Antrieb ab. Wir erwarten im Jahr 2020 ca. 12 Millionen elektrifizierte Fahrzeuge auf der Straße.
Denn ein Hybrid ist nicht nur sparsamer, sondern bietet auch mehr Fahrspaß. Der Elektromotor kann den Verbrennungsmotor unterstützen und das Auto so schneller beschleunigen.
This car is not only sporty, but also economical. It's a so-called plug-in hybrid. This means that the battery can be charged not only while driving, but also from the socket. The advantage? The car can drive in electric mode from the moment it started and uses less fuel overall.
Bosch combines the whole systems from the ICE to the pure electric powertrain in one company.
A hybrid is not only more economical, it's also more fun to drive. The electric motor can support the internal combustion engine, making the car accelerate faster.
These vehicles will combine, on the one hand, pure electric driving, which is a big fun, with CO2 saving, and that will bring the success of these systems.
In the year 2020, Bosch estimates that there will be around 12 million electric vehicles and hybrids on the road.